Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafizal bin Sulaiman, and today I'm going to talk about our group presentation. We have mini project which is calculator Sable CC, and we are from group 4. So these are our group members, which are myself, Muhammad Shafizal bin Sulaiman, Raihan Azhari bin Rosli, and Muhammad Haziq bin Hanafi. Okay, today I will walk you through the grammar behind a calculator grammar that we can use to interpret and evaluate mathematical expressions. This grammar serves as the foundation for building our calculator. So for our calculator.grammar, our calculator grammar file consists of three main parts, which are tokens, ignore tokens, and productions. So what is tokens? Tokens are the smallest units like numbers, operators, and symbols. So what is ignore tokens? Ignore tokens include spaces or new lines that the program skips over. So for the productions, these define the rules for combining tokens into valid statements like assignments or expressions. So to explain more about tokens, tokens are the building blocks of the calculator. Here is what each token represents. So tokens consist of number, identifier, plus, minus, multiply, and division, LPAR, RPAR, blank, semi, and equals. So what is number? Number is represents numbers like 1, 2, 3, or 4, 5, 6. So for identifier, it represents variable names like x or result. So for plus, minus, multiplication, and division, it represent operators. So for LPAR and RPAR, it represent parentheses for grouping. Equals and semi represent the equal sign and semicolon respectively. For example, um, in the input x, 5 plus 3, each part corresponds to one of these tokens. So what is ignore tokens? Ignore tokens is the grammar specifies that blank spaces, tabs, and new lines are ignored. This means the calculator can handle inputs like x equals to 5 plus 3 or x equals to open bracket 5 plus 3 and close bracket without any issue. So let's move to the productions. Productions define the structure of value statements and expressions. There are three key parts, which are statements. So what is statements? Statements are complete instructions like assigning a value to a variable, like x equals to 5 plus 3, or just evaluating an expression, open bracket 5 plus 3, and close bracket. So move to expressions. What is expressions? Expressions represent calculations such as addition or subtraction. For example, 5 plus 3 or x minus 2. So for terms and factors, these handle multiplication, division, and grouping with parentheses, ensuring the correct order of operations. Um, so for our calculator grammar has these key features, which are variable assignments. You can assign values to variables using equal, and operator precedence. It respects the order of operations, such as multiplication before addition. And parentheses, you can group expressions to control the order of evaluation. And for simple syntax, the semicolon ensures clear statement endings. Um, like if we take example code walkthrough. So let's take a look at a few examples to see the grammar in action. So let's say input that we use is x equals to 5 plus 3. Tokenized as identifiers equals number plus number and semi. Evaluates to x equals to 8, and input that we use is y equals to x times 2. And tokenized as identifier equals identifier multiply number and semi. Evaluates to y equals to 16. And the result is open bracket y minus 4 divide by 2. So tokenized as identifiers equals lpar identifier minus number rpar division number and semi. And it will evaluates to result equals to 6. Um, so, in summary, we can conclude that this grammar is the foundation of our calculator. It defines how inputs are structured, interpreted, and executed. With it, we can build a mini project capable of handling complex mathematical expressions.
Assalamualaikum warahmatullahi wabarakatuh to Madam Khairul Mazana, and today I'll be continuing the presentation by presenting calculator.java. Calculator.java is a command line Java program that evaluates arithmetic expression. It supports the supports operation is addition, subtraction, multiplication, and division. User can enter expression or type exit to quit the program. The program uses key components like a lexer for breaking down input into tokens, a parser to generate an abstract syntax tree, and a translation class to evaluate the expression. It accepts user input, processes it, and outputs the result. For example, if you enter 3 plus 5 times 2, it correctly applies operator precedence to give 13. The translation class traverses the AST, handling addition, subtraction, multiplication, division, and even checks for division by zero to prevent errors. Calculator.java demonstrates the use of parsing and AST traversal to evaluate arithmetic expression in Java. It also provides a solid foundation for understanding compiler principles like parsing, AST creation, and evaluation. Thank you.
Hi and Assalamualaikum. So my name is Raihan Azhari. So today I'm going to do testing on CSC. So first we're going to do the first impression, which is 2 plus parenthesis 5 multiplied by 2. So this shows that it does the thing in the parenthesis first, then it does the additions. So next we want to do 2 plus 10 multiply by 5. So the result is 60. As for the third testing, we're going to do double parenthesis minus 6 divided by 2. So the result is 12. So the last testing is to test whether it can detect error. 6 divided by 0 is error, because 6 cannot be divided by 0. So I think that's all for the testing on CBCC. Thank you.